This video will cover a solution guide to problem 38 from chapter 8. Two cars collide at an intersection. Car A with mass 2,000 kilograms is going from west to east, while car B of mass 1,500 kilograms is going north to south at 15 meters per second. As a result, the two cars become enmeshed and move as one. As the expert witness, you inspect the scene and determine that, after the collision, the enmeshed cars moved at an angle of 65 degrees south of east from the point of impact. How fast were the enmeshed cars moving just after the collision, and how fast was car A moving just before the collision? This is a conservation of momentum problem. Momentum in the x and y directions are independently conserved, so we will use this fact to solve for the final velocity of the enmeshed cars and the initial velocity of car A. First, let's start by drawing a picture of the situation being described and figure out what information we have been given. Before the collision, car A was traveling from west to east, meaning its velocity was in the positive x direction. Car B was traveling north to south, meaning its velocity was in the negative y direction. So, for our initial condition, all of the momentum in the x direction is coming from car A, while all the momentum in the y direction is coming from car B. After the collision, the cars become enmeshed and move off at an angle of 65 degrees south of east. In other words, the velocity is at an angle of 65 degrees below the horizontal. This means that the velocity has a component of the final velocity multiplied by cosine of theta in the x direction, and the y component is negative with a magnitude equal to the final velocity multiplied by the sine of theta. Now, let's find the speed of the enmeshed cars. To do this, we will use conservation of momentum. The total momentum in this situation is conserved, which means that the momentum in the y direction is conserved and the momentum in the x direction is conserved. Since we are only given the speed of car B and it's only moving in the y direction, we can use the conservation of momentum in the y direction to solve for the final velocity. Initially, the momentum in the y direction is equal to the mass of car B multiplied by its initial velocity. After the collision, the momentum is equal to the mass of car A and B multiplied by the y component of the final velocity, v final sine theta. Rearranging this equation to solve for v final and substituting the values given in the problem, we find that the enmeshed cars move off with a speed of 7.1 meters per second. We now have enough information to solve for car A's initial velocity. Using conservation of energy in the x direction, the initial momentum is the mass of car A multiplied by its initial velocity, and the final momentum is equal to the mass of car A and B multiplied by the x component of the final velocity, v final cosine theta. Rearranging this equation to solve for car A's initial velocity and subbing in the values given in the problem, we find that car A came into the collision with a speed of 5.3 meters per second.